So let's take, for example, we have a negative power, and we'll say it's x to the third times x to the negative 10th. Well, the only rule that there is for negatives is that we can't have a negative. So to get rid of it, what we can do is actually create a fraction and turn it into, we can put it over 1, and then take that value that has the negative exponent and move it across the fraction bar. So I would end up with x to the third divided by x to the 10th. And now it's a division problem. So when I divide fractions, I would subtract and this would go away. So, but I would still have this 10 down here. I would just take away 3 from it. When this goes away, I'm just left with a 1, and now I have x to the 10 minus 3, which is x to the 7. That was what we did Friday. The rest of the week, we pretty much worked on factoring. And we talked about prime factorization. Which is factoring with prime numbers only. That's numbers that can be multiplied by themselves from 1, and that's it. And then we talked about GCF, which is the greatest common factor. So if I had, let's say, 4x squared plus 16x minus 20, what I could do is I would look at the coefficient first. And remember that the coefficient is the number in front of the variable. So I'd look at this 4. And my factors of 4 are 4 and 1 and 2 and 2. My factors of 16 are 4 and 4. I'm sorry, let me start over. Factors of 4 are 4 and 1 and 2 and 2. Factors of 16 are 4 and 4 and 2 and 8 and 1 and 16. And then I look at my constant. My constant has factors of 4 and 5, 2 and 10, and 1 and 20. So all of them have a common factor of 4. When I pulled 4 from 4, I was left with 1. Okay? I was left with 1, so I put that up above. When I pulled 4 from 16 by dividing, I'm left with 4. And when I pulled 4 from 20, I'm left with 5. Now I need to look to see if I have a variable with each one of my terms in my polynomial. Since I do not have a common term, then, or a common variable in all of my terms, then I would just leave it as my GCF of 4. I'm going to give you one more example, and this example actually will be on the quiz tomorrow, so it's a good thing you're watching tonight. So if I have 2x squared plus 10x plus 3x plus 15, I'm actually going to break these up into two different polynomials. Okay? And I can do this one of 2 ways, and I'll show you both ways here in a second. But the first way, we're going to break these two up. Since 2 and 10 have the common factor of 2, I'm going to pull 2 out. They also both have an x. So I'm going to end up with x on the outside. Now what am I left with on the inside? I have an x that I still have to get to an exponent of 2. Now to get from 2 to 10, I have to multiply it by 5. So when I simplify this and I factor out a number, I factor out 2x, and I'm left with x plus 5. Now that means I have these two here. Both of them are divisible by 3. So I'm going to remove a 3. However, there is not an x in both of these terms. So I'm going to leave x on the inside, and 3 times x gives me 3x. Now, 3 times a number gives me 15, and that number is 5. If you take a look here, I have two terms in parentheses, and they both happen to be the same term. And I'll show you why that is now. So this is an acceptable answer. But if we go back to our original problem was 2x squared plus 10x plus 3x plus 15. I can put these two together. So I would end up with 2x squared plus 13x. Since they are both x's, I can combine those since they are like terms, plus 15. As it turns out, I know that I can pull out an x plus 5 from both of these. Okay? So let's go back to our box that we talked about all day today. And I know that an x plus 5 is going to be pulled out. And I need to end up with a 2x squared here. And I need to end up with a 15 here. So if I know what I'm going to end up pulling out, and I have this factor and this factor, or this product and this product, I can figure out what factor I need to multiply them by. And as it turns out, to get from x to 2x squared, I need to multiply it by 2x. And 2x times 5 would be 10x. And then I need to figure out what number I need to multiply by 5 to get to 15. And that number is 3. And 3 times x is 3x. And I can double check that by combining my like terms and then writing out my polynomial. And I end up with the same one. The last thing that we talked about was multiplying polynomials. And if I have 3x plus 3 and x minus 7, I can create a box. And the way that I create the box is I start with the length, and since there are two terms, I divide this box into two sections. And I write those terms in each little section, just right outside the box. And now I need to do the width. And since there are two terms in the second polynomial, I am going to break it into two. So I would write x minus 7 outside. And now I just combine them by multiplying. So I do 3x times x, and I get 3x squared. Now I would do 3x times negative 7, and I would end up with negative 21x. I would multiply 3 times x and get 3x. And I will multiply 3 times negative 7, and I would get negative 21. Well, 3x and negative 21x look the same. They have the same variable with the same exponent. So I can combine those. And those are the only two that I can combine. So I'm going to write the 3x squared out. I'm going to combine these two. And negative 21 plus 3 is negative 18x. And then I could not combine the negative 21 with anything, so I just write that down. Good luck on your quiz tomorrow, and we will see you then.